Students, due to some technical issues, there was an interruption. Please don't worry, right? So this is the condition. So we have seen all these things. Tan theta plus mu divided by minus mu tan theta. The same relation I'm writing here. V square by Rg is equal to mu plus tan theta divided by minus mu tan theta. V square is equal to Rg into mu plus tan theta divided by minus mu tan theta, where mu is the coefficient of friction between the tire and the road, right? So this is the express square of the relation we are getting. So we can find V is equal, therefore V is equal from this relation. V is equal to square root of Rg into what? Mu plus tan theta divided by 1 minus mu tan theta. So this is the safest maximum velocity with which a car, a vehicle can negotiate a banked road. Banking angle is equal to theta. So this is a very simple thing, right? V is equal to means the safest velocity. So we have to always think that this value, that means the velocity of the body should not exceed this value. If the velocity of the vehicle exceed this value, R is the radius of the circular path, G is the acceleration due to gravity, and mu is the what? Coefficient of friction and all this. If you calculate this much, that velocity must be always kept. That velocity with that value of the velocity of the vehicle negotiate, that will be a safest way. If the velocity of the body coming to that point of the banked curved path is greater than this value calculated, then the vehicle will surely skid. So the safest velocity must be V must be less than or equal to square root of Rg into mu plus tan theta divided by 1 minus mu tan theta. So this is the safest velocity. If mu is equal to 0 in this expression, that means the coefficient of friction between the road and the road is so smooth and the friction is very, very less, considerably less, then what will be the value? Then we can write if mu is negligibly small. That means friction is negligible, mu is equal to, mu is more or less equal to 0. Then what will get? This mu 0, this also 0. Then what will get? You will get V is equal to square root of Rg into tan theta. Rg tan theta you will get. This mu 0, this also 0, right? 0, 1 minus 0 is equal to 1 only. You will get this value. V is equal to Rg tan theta, where R is the radius of the banked circle road and G is the acceleration due to gravity. Theta is the banking angle. BANKI. This is banking, sir. Banking it is called. BANKNG. Banking angle. Banking angle is theta. So all these things you remember, and also you will be able to do this problem, do problems in this topic using these relations. V is equal to Rg into mu plus tan theta to 1 minus mu tan theta. Or V is equal to Rg tan theta. So these are important. Please note. Next means most of the time you might have seen that a cyclist when he negotiates a curved road, when he negotiates a curved road, he lean by an angle from the vertical. Lean by an angle from the vertical he has to lean. So that also a very interestingly you can see that, right? Suppose a person he is negotiating a curved road like this, and this is the position of the cyclist. Cycle with the person, yes. And that time what he has to do, this is vertical and this is horizontal, right? Horizontal. So this is theta. Cyclist, man and a cycle and other things all together to draw it is difficult. That is why that position, the tire of the vehicle is touching the ground at this point. This is the vertical and this is the horizontal. Okay. So actually what is happening is the person when he is negotiating the curved path, when he reaches the curved path, he has to lean. That means he cannot sit straight and turn the road, but but at reaching at that point, he has leaned from the vertical by an angle theta. This is to provide for the necessary centripetal force. Otherwise, he will skid. If you sit straight, then his vehicle will not take the turn, right? So what has to is he has to lean from the vertical by an angle. This is also a good question. Why a cyclist, when comes to a turn, a level circular road, he leans from the vertical. This is to provide for the centripetal force, right? This is the condition. So in this case, what is called, suppose this is the central system, the center of the system. From the center of system means the vehicle, the cycle, and the man who's that center of gravity. So that is this point. Through the center of gravity, the entire weight is acting like this is mg. Am I correct? And suppose the vehicle is touching the road at this point with a force, therefore force of reaction is acting along this direction. Why that force of reaction? Because the entire body is touching the ground, it is giving a force in the downward direction in an inclined manner. So the force of reaction is acting in a direction opposite to that. That is R. R can be resolved into two components, right? One is R cos theta and other is R sin theta. Am I correct? Okay. One is R cos theta and other is R sin theta. Right. This is R cos theta. This is R cos theta. This is theta. Naturally, this also will be theta. Naturally, that is R cos theta. R cos theta. And this is R sin theta. R sin theta. This is the circle road. The person is turning like this. Right? For your understanding, only I made this one. Yes. The curved road at this particular point, the system, the man and the vehicle is pushing a force, putting a force on the ground in this direction. The reaction force is acting along the same straight line, but in the opposite direction, right? Mg is acting downwards. R cos theta, R cos theta. R can resolve into two components. R means normal reaction, right? Reaction force, not normal reaction, reaction force. The reaction force is resolved into two components. One is R cos and R sin theta. Am I correct? Okay. In this case, you see that R sin theta is toward the center of the circular path. So this is a circular path. R sin theta is toward the center of the circular path. Right? Which are the balancing forces? R sin theta provides for the centripetal force, and R cos theta is balancing mg. So here also we can write mg is equal to R cos theta. I can write. I'll write here mg is equal to R cos theta. We can write, and mv square by R is equal to mv square by R is equal to R sin theta. We can write. Am I correct? This is equation number 2. This is equation 1. This is 2. 2 by 1 when we write, that means mv square by R divided by mg is equal to R sin theta divided by R cos theta. R cos theta. M and M cancel. We will get v square divided by rg is equal to simply tan theta we are getting, right? Or v square is equal to rg tan theta, or v is equal to square root of rg tan theta. So this is also very simple relation that we have already seen. Same relations, only similar relation. That means the person is coming to a curved path. That curved path has a radius, right? And theta is the angle made by the person with the vertical. How much he is leaning from the vertical, that is this angle. This is not banging angle, but this is leaning angle. Angle, how much he is leaning from the vertical. So the person's, that tan theta you have, G you have, R you have. This velocity, RG tan theta, that is a particular value. The person's velocity, the cyclist's velocity should not be greater than this value. If the velocity of the person is greater than root of RG sin tan theta, then the person will skid at the curved path. So the safest velocity in this case also we must write, V must be less than or equal to square root of RG plus square root of RG tan theta. Where theta, remember, always remember, theta is the angle made with the person with the vertical when you negotiate a curve. So that the question is very simple. Why a person, when reaches a curved path, lean from the vertical to negotiate the curve? Then only he can provide for the centripetal force. Centripetal force is a safest force. Using that, he can easily negotiate the curve. With the help of that, he can negotiate the curve. So these are the examples of centripetal force acting on bodies which are taking turns, right, or which are moving in circular path. So this topic is about this much only. Tomorrow we will do some numerical problems related to this topic. Then we will go for work power energy. Right? Till then, bye bye. Thank you very much.